Now on the 9.1 quick check, okay, was the first question is talking about atomic orbitals. Okay, and it says how many orbitals are on the fourth energy level? Well, first thing, when we're talking about orbitals, we're talking about these little circles, okay, that we have here. So those little circles are the orbitals. And we say, well, for on the fourth energy level, that's a little ambiguous. We're talking about the level where n equals 4. So we're talking about like the fourth floor of the hotel. And it means everybody who's 4s, 4p, 4d, 4f. So how many orbitals are there? Okay, it turns out that there are n squared orbitals. Okay, we can look at them. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So when n equals 4, there are 16 orbitals. When n equals 3, there are 9 orbitals. 4, 5, 6, 7, 8, 9. When n equals 2, there are 4 orbitals, n squared. And when n equals 1, there's 1 orbital. So the number of orbitals is always n squared. Number of types of orbitals, number of subshells, that is n. So if we say the word subshell, okay, there's an S subshell, there's a P subshell, there's a D subshell, there's an F subshell. So on any level, in this case 4, there are 4 subshells, n squared, 16 orbitals. Okay, what's the maximum number of electrons that can occupy a 5d orbital? Well, any orbital, any d orbital we're talking about are 5 orbitals, and in 5 orbitals we can have 10 electrons in total, so the answer here is 10 electrons in a 5d orbital. Okay, on the next question, for electron configurations, we want to do the following: the long form, short form, total valence electrons, total number of electrons. So our first one here is chlorine. And for chlorine, we're saying using this blank periodic table is going to be useful, and this exact table will be on the test for you. And you should look at it and say, okay, these are 1s. Okay, here's 2s, here's 2p, 3s, 4s, 5s, 6s, 7s, 2p, 3p, 4p, 5p, 6p, 7p. The D's here, these start with 3. So 3D, 4D, 5D, 6D. And the F's start with 4s. So it's 1 for the S's, 2 for the P's, 3 for the D's, 4 for the F's, 4F and 5F. Okay, so we are looking for, we are looking for chlorine. And chlorine, we have to remember on our periodic table, is right here. Okay, it's a noble, it's a halogen. There's fluorine, there's chlorine. So we're looking at this guy right here. So if we want to do this, okay, we look at the periodic table, we say chlorine has 17 total electrons. And because it's in this column, we know that there are 7 valence electrons. Okay, the long form from the periodic table, we can see it's 1s. Okay, then it's going to be 2s, 2p, 2s2, 2p6. Then it's going to be 3s and 3p, 3s2, and the 3p, because it's right here, we haven't quite filled it up, it's 3p5. So that's the long form, 1s2, 2s2, 2p6, 3s2, 3p5. Now we want to say, okay, if I want to do the short form, I go over to the end and back up 1, so I'm here, and that is neon, so I can say brackets neon. Then I go back to the beginning of my chlorine row, so that's 3s, 3p. So 3s2, 3p, 5. Now something we are not asking, and that is which of these electrons here is our valence electrons, are the valence electrons. And we have 1s and 2s and 3s, whichever one are the highest orbitals, the largest, the furthest out, the outermost, those are the ones that are valence. And we can see that there's 1, 2, 3, 4, 5, 6, 7. There are 7 valence, and that's what we said in the first place, 7 valence electrons. So that is this kind of problem. Okay, we'll do it again. Here's cobalt. Okay, so I'm going to go fill in a little bit of these. So this is 1s, 2s, 3s, 4s. And this is 2p, 3p, 4p, 5p. And these are 3ds, 4ds. And looking at my actual periodic table, I can see that cobalt is right about here. Okay, and it's number 27. So that means I have a total of 27 electrons in my neutral atom. And we're going to find out that everybody in here has 2 valence electrons, and we'll see that more in a little bit. So we say these all have 1, these all have 2, all these have 2. Down here, anybody in here has 2. Okay, then we go 3, 4, 5, 6, 7, and these guys have 8 except for helium, which only has 2. So we're going to do cobalt. So the long form, we can just see we're going to do 1s2, 2s2. So we're getting this guy, we're getting this guy and this guy. Okay, 2p6. Then we go 3s2, 3p6. Then we get to the row with cobalt, 4s2, 3d, 4s2, 3d. And then we have to count kind of carefully on our actual periodic table. We find out that it's got 7. It's a little hard to do with this blank table, but you can do it with your real table. Okay, then we say, well, what's our short form? So we're going to go to the end and go up 1, and that guy is going to be argon. And then we just do the row where cobalt is, so 4s2, 3d, 7. Now, we didn't ask it, but if we did, say underline the valence electrons, well, we have 1s and 2s and 3s and 4s. The 4s, okay, that is our valence electrons. So we can see that we only have 2 valence electrons in the S, and that's what we said. We said we had 2 valence electrons, okay, and that's what it is for cobalt. Okay, we'll do again here for tin. Okay, now tin is even farther down. Okay, and tin is right about here. Okay, so I'm going to go back and fill in some of these orbitals. So 1s, 2s, 3s, 4s, 5s. Okay, this is the p's are 2p, 3p, 4p, 5p. And the d's start with 3ds, 4ds. And we get to a point where you don't really have to even fill those in. You'll know what they are as you work through this. So we're going to say total electrons. Okay, on tin, if we look that up, it has 50 electrons. And how many valence electrons? Well, it's in the same family as carbon. And if we look at that, that's 4. These all have 1, these have 2, these guys have 3, carbon family has 4. So 4 valence electrons. Okay, long form. Okay, we have 1s2, 2s, 2s2, 2p6. We're going to have 3s2, 3p6. We're going to have 4s2, 3d10, 4p6. We're running out of room. 5s2, 4d10, and we're going to get to the 5p, and it's only going to have 2. So I'm going to put it down here. So 5s2, 4d10, and 5p, and if we can see on our real periodic table, that's in the second space, so it's 5p2. Now for the short form, okay, we're going to go back over here and up, okay, and that's helium, neon, argon, okay, that is krypton. So the short form, we're going to start off with krypton, and then we go back to the row of this tin, so it's 5s2, 4d, 5p, so 5s2, 4d10, 5p2. Now again, we didn't ask it, but if you were to underline the valence, you're looking for the valent ones on the outermost shell. So here are the 5s, those are the outermost. So these guys here, those are the outermost, those are the valence electrons. We have 2 here, we have 2 here, and that's where we got the 4 valence electrons. And that is the tin. Now for tin, the next question is related, and the next question is, what about tin 4+? Because we learned the stannous and stannic ion, and this would be the stannic ion. Well, the first thing is if we said, okay, I have tin 4+, that means it lost 4 electrons. So instead of 50, we would have 46. And before we said this had 4 valence electrons based on where it was on the periodic table. And so, you know, we're going to say it has 0 valence electrons. It's lost all 4 of its electrons. So now what's the long form? Well, the long form is going to go back. It's going to be the same as the long form we had before, except we have to take away 4 electrons. And when we take them away, we take away the valence. We take away the outermost electrons because those are the most easily taken away. So if we look at this and say, well, who's our farthest ones out? these guys, and these guys. So we're going to take those electrons away, we're going to take those electrons away, those 4. So what we have left is our answer. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 4d10. That is the answer for this, and I'll take a second to write it out. Okay, so there it is. It's the exact same I had before, only I left out the 5s2 and the 5p2. Okay, my short form, okay, exactly like we had before, is still going to go back to krypton, only we're going to leave out the 5s2, 5p2. So this answer here is going to be krypton. And the only thing we have left after krypton is 4d10, because we're taking out the 5s. And that is SN4+. So again, just notice that for FN, SN, if you want to do one of these positive ions, look at the neutral one first, and then go back and get rid of the outer electrons, the outermost electrons. They're the ones that go first. Okay, the last thing here is ions. The valence electrons of an unknown element X are Ns2, Np3. What ion will that form? Well, that's a little bit confusing because of the way it's said. So Ns2, Np3, that means that its valence electrons could be 2s2, 2p3, or it could be 3s2, 3p3, or 4s2, 4p3, okay, et cetera, et cetera, et cetera. So that means it's going to end up being right here in this box. Okay, those guys, somebody here in this row. And who are we talking about? We are talking about the nitrogen family. Okay, so nitrogen, phosphorus, arsenic, etc. Okay, so what happens there? These guys don't form any ions. These form -1 because if it gains electrons, it'll have a noble gas configuration, -2 and -3. So what ion we're going to form? We're going to form a 3- ion, okay, because it's in that family. So that family all forms 3- ions. And that's the answer to the quick check.